All right, good morning. Thank you so much for being here. I really appreciate the invitation to speak here. It's a great pleasure. I want to talk about something we deal with every single day. Whether you're a programmer or an architect or team leader and manager or just a normal human being running around the world, this is something we need to deal with every single day, which I want to start with talking about decisions. How many of us had to make a decision this morning already? Yeah, all of us, right? And the hardest was waking up, wasn't it? That's the hardest part of every single day, is to decide, should I hit the snooze or should I wake up? And that's really hard, but we have to make decisions every single day. But making decisions is not really easy. It can be really hard, but when it comes to making decisions, we want to think about how do we go about making decisions? In our mind, we often think about decisions, oftentimes, as this little switch that we throw. Do we want to drink coffee or tea? Some of us, that's very obvious decision. Some of us have to make a decision on the day we want to have a drink. What should I have for breakfast? Should I take the train or should I drive today? Or ride a bicycle? A lot of these, we make decisions, and we may think about decisions as just throwing a switch as a, yes or no. But as it turns out, life is not really that simple. Making decisions is really hard, but why is it really hard for us to make decisions? But what makes it really hard for us is we look at others, and they seem to be really having a good time making decisions. It's really easy for them. Why are the decisions hard for me when it can be really easy for them? This is something that goes through our mind all the time. But as it turns out, where we are makes a difference to where we want to be. This is one of the challenges we face every single day. A decision may be really easy for this other person because they're not where I am. From where I am to get to where I want to be may be really hard or easy compared to the other person from where they are. So a lot of times we tend to really either forget or ignore the situations we are in, and yet we want to really make this transition to where we want to be. But I think understanding where we are is one part of making the decision in terms of how we can make the transition. But one of the things I've realized over time is when it comes to making decisions, I would want to say this is something we want to clear our mind when we get into making the decisions. And that is really thinking about we need to have the will to make the change for our decisions to be successful. And a lot of times we may get into a meeting, we may be talking to people, and we are trying to make an effect to a change, and we see resistance in the particular approach, or people are reluctant to really make the change. But really asking that question, are we willing to make this change, can make a huge difference in our ability to actually work towards making a particular decision. And I want to relate this to an experience I had about 2 years ago. And I wanted to build a house, and it was a semi-custom house. And while I was building the house, I would tell people that I'm building a semi-custom house. And almost all the time when I mentioned that, the immediate response from people really scared me. They would say, oh my gosh, good luck with that. I'm sorry to hear it. I'm like, oh my goodness, why would you say that? And they said, well, we built a house and it went horribly wrong, and everything that could go wrong went wrong. So that really made me scared because, as you know, building houses is a very huge investment. And we were building the house as we were just coming out of the pandemic. And what if things go wrong? What if we lose a lot of money? What if we get everything done wrong? And as I was going through that experience, I tweeted one day this particular observation. And that is, those who compare building construction to software development understand neither one of them. What I realized was that we often think that building construction is so rigid that we got to make all these plans up front because things can go wrong, and if you don't really plan well, it's going to really be a bad idea. Well, I had a builder who doesn't know anything about software development, but he proved me wrong in so many of my beliefs and showed me that building construction can be very different as well. And I went to him and I said, well, you're very agile. And he's like, what does that even mean? He doesn't know the word agile, thankfully. But he was truly agile in the sense of being agile. And there are so many lessons I learned from him in the construction. He doesn't know anything about software, like I said. But one of the things I saw was just absolutely amazing for me. I had a guy who showed up to fix a little, sheet of net we wanted to put on the house while we're building it. And the guy walks in, completely independent to this builder, and he walks in and says, who's your builder? I'm like, I say who the builder is, and he's like, I'm truly amazed. I've never seen a construction place this clean ever. Well, he had a board that said, clean up at the end of the day or we'll send you the bill. And he really meant about cleaning up things, refactoring at the end of every day, if you will. But there's a lot of lessons I learned from him. But one lesson that absolutely blew my mind. I had an architect who drew up the plan for the house. Don't get me wrong, amazing architect, fantastic. And I in fact told the architect he's got this ability to read my mind. Before I could even tell him what I want, he was up on the top. He's like, you would like this? It's like, how do you know this? You're reading my mind. But the architect came down, looked at the place, and I wanted to structure the house in a certain angle, all that done. And when he made the plan, he said, your house is going to have 3 steps to walk into the house. And I told him, well, you know what? That's not going to help me. I've got parents who live with me. They're old. And it's really hard for mom and dad to walk into the house every day when there are stairs. And I'm not going to be young all the time. And there's going to be a day when maybe I need a wheelchair to go in. So it'd be great if you can remove those steps that take me into the house. And the architect said, sorry, you cannot do that. Because there is an elevation and all these engineering things, and you got to really place it in this angle. So we have to have these steps to go into the house. And I said, okay, that's fine. In the garage, can you please put a ramp? I can use a wheelchair ramp to, wheel in. Oh, no, you don't understand. There's a slope, and there's engineering requirements. I can't just throw a ramp anywhere you want to. So I'm like, okay, darn it. I will live with the 3 steps. Thank you for, all that effort. And we were about 2 hours away from the building site. I had work to do that morning, 6:30 in the morning. And I get a call from Dave Hammer, amazing builder. And my wife picks up the call, and Dave says, hey, we are at the building site. We're here to dig the hole for the foundation. And my wife says, well, that's great. Thank you for letting me know, Dave. But Venkat is busy today. We're not able to come over there. He's like, no. The reason I called you is, do you want a 0 entry? And she's like, what does 0 entry mean? You can actually walk into the house with no steps at all. And she said, well, thanks for asking, but Venkat spent a lot of time with the architect. And they found out you cannot build without steps. And Dave said, well, that's great, but leave the architect alone. I'm here to dig the hole. Let's talk about it. Have you ever heard this one before? Don't worry about the architect. I'm writing the code right now. And she's like, really? She's like, yeah, don't worry about it. But I'm here digging the hole, and I know you guys really wanted, 0 entry. I just want to make sure you're okay with it. And she's like, well, I can't talk to Venkat right now because he's teaching right now, but I can almost tell you, absolutely, yes, go for it. Well, he said, no guarantees, but just wanted to get you okay with it, but we'll get back to you. And he works with the guy who's digging the hole for the foundation. They come up with a plan, redraw the entire architecture within a matter of hours, and sends it back to the county for approval, sends a copy to us and says, make sure this is all okay. And my head is spinning right now because all the elevations are different. So when we finished the building, this house is right now, that's Dave Hammer, an amazing guy. And what we ended up with was that, with absolutely no steps to walk in. And I asked, and this was just one example of what Dave did. And there were so many other occasions where we'd have something in the plan, and he would call me up and say, I know this is what you really want, but I want to make sure I can make the change for you. And I said, wait, I was told that you cannot make these changes. And I asked him, but why do you do this? And the answer he gave me truly made me humble. He said to me, Venkat, I'm going to build this once, but you're going to live there for a long time. I need to build this for you. And I said to myself, if only my programmers use the same words. They're like, I wrote the code already, like, so? And yet, here is a person who is building a house, making changes every step of the way, thinking about me, the person who wants to live there, not about what he wants to build. And that is a lesson I really learned about, one thing that I could just absolutely not emphasize enough. What Dave had was that one thing that makes a big difference, which is the will to change, the will to reconsider what we are doing. And it was will that made the difference for this man, to make him such an amazing builder in the world, in my opinion. And when we built it, we were the most happy customers ever, in my opinion, because I sing his praise every day. When I live in the house, I talk about him, and it's like, oh, if anybody visits my house, I immediately start talking about Dave. Well, I'll tell you what he did here, what he did there, and every one of them is positive, because he showed me the will to change is the very first step in making decisions. Well, of course, let's be serious about this, right? A lot of things are not as easy as building a house, after all, right? There are very highly critical decisions we have to make. Like, for example, that one. Whether it's an over-orientation or an under-orientation. I was not even aware of this critical decision we have to make. Just a quick show of hands. How many of us use the over-orientation? Okay, there we go. How many of us use an under-orientation? Minority of people reluctantly raising the hand, like, should I or not? Yeah, well, thank you. And, well, obviously the minority is wrong, right? Democracy rules. The ones who raise the hands, the mass are the correct. But this can be serious business. I was kind of curious, so I decided to Google for some more details. And I came across a shocking piece of information. You may or may not be aware of it. And that is the correct way to hang toilet paper according to science. Hanging it the wrong way can result in absenteeism, workers' comp, and even business-busting lawsuits. Oh my goodness. How serious this could even be, you may think about it. But as it turns out, life is not that simple. Now, the question you want to ask is, now the problem now is, I cannot go to the restroom without thinking about this anymore. Because every restroom I go to, I'm like, how is this? Is it over or under? I'm in an airplane. Does anyone remember how it is in an airplane? It's usually under. And why is it? Well, people with pets and children, small children at home, maybe want an underhanging, unless they want paper towel everywhere in their house. So there are decisions you make based on your situation. So if you have little ones running around or little pets running around, you might choose the under orientation, versus if you're like me with no little kids and no pets at home, maybe an over orientation. But there is no clear choice which one is better. There are situations that may lead you to do one or the other. But very few things are binary in nature like that to decide yes or no. For example, is it good to have ego? Or should we not have ego at all? Well, it's easy to say, oh my gosh, we shouldn't have any ego. But what happens if we don't have any ego? I think we're going to have really low confidence. What do you think? I don't know. What do you like? Oh, anything. And it really is frustrating to work with people who don't have any confidence at all in what they do. But all the way to the other extreme is really bad too, overconfidence. This can be really annoying to work with people like that too, right? Or to live with them. And we probably need a balance. We need to have enough ego to have self-confidence, but not go overboard with it. And that's a choice we have to make every day. How do we bring up enough to have confidence, but not go overboard with it? For example, the question, how are you? I've got a lot of friends in Sweden. I go there quite often to teach courses for my clients. But one morning, I walked in. really nice people, but they had a little chuckle. They were, discussing something, and I felt like their chuckle was related somehow to me. And so they looked at me and said, "Hey, Venkat, how are you?" And they said, "Actually, I want you to do this. Take a second, if you would please. Turn to the person to your left or to the right and ask them, how are they?" Go ahead. Now, so that's what they did for me. They said, "How are you?" And my answer to them was, "Great." And they all laughed. And I said, "Why are you laughing when I said great?" And the person said, "I told them that's what you're going to say." And I'm like, "Really? Why would that be funny?" I asked. So what if you say, "How are you?" What if the person says, "Terrible"? You're like, "Oh my gosh, that's not what you want to hear, clearly." But what if you hear, "Great"? That's how you know you are sitting next to an American, right? So we say, "Great, I'm pretty damn good." We don't want to say, "I'm fine." You're like, "What happened to you? You should be great," right? And that's how you know you're an American. And that's what they told me. "We just want to do a litmus test to see where you're from." And I said, "You're great. That means you're from the US." And I said, "Well, then what do you say?" And they said, "We say they're okay. Not great, not bad. Something very moderate in between. Very humble in their nature." And that's something I learned from my Swedish friends. That's an amazing attitude for them to have. I'm not going to say that. I'm like, still great, right? Because it feels good to be damn great, isn't it? But that also shows us a balance in our thinking, something for us to learn from. Do you want to be a pessimist or an optimist? Well, you probably know this already. I am an eternally optimistic person with a little bit of pessimism when it's needed. But I also live with and work with people who are not as optimistic as I am. And that's not a bad thing, because sometimes we need people who are a little suspicious about things too. But as I came to know about the story of a pessimist and an optimist who walked into a bar, what could go wrong when you have these two people of polar extreme walking into the bar together? Well, I was told the bartender was curious. He asked, "How are things?" And the pessimist decided to chime in. And he said, "Oh, it cannot get any worse." And the optimist said, "Yes, it can." Well, the point really is, what about being a pessimist versus optimist? I think over-optimism is dangerous. We will make really bad mistakes. Or pessimism is dangerous. We can't make any progress. I think what we really want is something in between. This is something I learned from my son, actually, because he decided to give me a perspective very different from what I've been telling people to do. And so I started asking the question, is he right or am I right? And so should I say yes or should I say no? And I've been telling people the following. The more yes you say, the less you will deliver. And this is one of the problems I see with a lot of programmers. Can you do this? Yes. Can you get it done by tomorrow? Yes. What that means is we're not going to get anything done. So the more yes we say, the less we actually will deliver. So I've been telling people, grow up to say no. Have the courage to say no. And I was talking to my son. He graduated about 2 years ago, actually here from Illinois, not far from here. And he's been in the workforce for about 2 years. He's just getting close to finishing 2 years. And I was talking to him one day, and he said, "But Dad, I say yes to everything." And I said, "My son, that's bad." He said, No, Dad, that's actually great. I have actually done so many things in my work because I keep saying yes. I've got these new opportunities, I've got these promotions, I've got these new deals that I'm working with, we got a new design I'm working on, I'm taking more in charge, and all because I've been telling people to give me stuff to do. And I kind of sat back and said, well, clearly he is succeeding in what he is doing, so he is right, or am I wrong? What's going on here? And I realized that both of us are actually correct. When you are a novice, like my son is, I wouldn't call him a novice in the sense of a novice, but compared to how many years I've worked, he's definitely on the other end of the spectrum, versus an expert, like a lot of people in this room could be. And when you're a novice, you really want to gain experience. You need all the opportunities you can get. And honestly, I will think about myself 35, 40 years ago. I did crazy things I would never want to do today. I would travel so much distance with no food so I can go get this particular opportunity with a client who wants me to do some work for them. And yes, I was that person 30, 40 years ago saying yes to everything and more. Versus when you're an expert, you want to really focus on succeeding. You want to maintain your reputation when you are really an expert. And so what works for a novice doesn't work for an expert. And this is where we need to really ask the question, should I say yes or should I say no? Well, actually, that's not a simple answer to give. So we want to really think about how do we approach it. So when you're a novice, yes, say yes eagerly. Yes, yes, of course, bring it on. I want to do this and more. And as you begin to become more experienced, begin to say no, but nicely. And by saying no, you are clearly saying, these things are not my priority, and there are these things that I really want to focus on. And if you are not saying no at this time, you're not going to really be able to become that expert with reputation as time goes on. And also, this is one of the things people often misunderstand. You're not saying no to the person. You're not telling no to your boss. You're telling no to the misplaced priority your boss is placing on you. So it's important to make it clear, I'm not saying no to you, but this is not going to help us to succeed, so I have to say no to that particular task that you want me to work on. So yeah, you're saying no to the task, not to the person. So start saying yes in the beginning, but with more experience you gain, start saying no more often. And this is a shift we have to take in terms of where we are in our career. And again, depends on what we do. I might be a programmer, and I'm a senior programmer maybe this time, and I'm going to say no to a certain programming-related task. But the same me might be a beginner as an architect, and I should be saying yes more often right now rather than saying no in the area of architecture. So it's not the person who always says yes or no, but it's a position in which you are. You might have to say yes or no depending on what you're trying to do. So maybe say no as a programmer, but maybe yes as an architect, depending on the transition you are in your career. But life is really an act of evaluating these trade-offs. All I've been talking about right now is these trade-offs we have to take all the time. There is no way to say this or that. We're evaluating these trade-offs. You're not really making decisions. You are really evaluating trade-offs. That's what we do every single day. So you rarely decide on things in isolation in general. You don't get this luxury. However, we may have that in our mind. I'm not making a decision, but instead I'm really evaluating the compromises of things that are in front of me. The more we put that out in the open and more we discuss that, it becomes less painful and more obvious what we are struggling with in general. So rather than thinking about decisions as a switch, it turns out decisions every day are dials. That's what we do every single day. We're not flipping a switch back and forth, but we are sitting there and doing this with the knobs. And like the gentleman over there are dealing with the knobs in terms of, hey, is the volume good? Is the clarity good? And they're making these adjustments to make sure everything is within a range. You're not really trying to pick a number, but all you're trying to do is to fit things into a range that is acceptable, so everything you care about fits into their own respective ranges. That's what we are trying to do. So we are dealing with these dials every single day. For example, this is right outside my backyard. This was truly the winter of last year. We had snow, almost relentless snow for 2 months. And it was extremely cold. One day I called one of my friends and I said, "It's very cold." And he's like, "Okay." And I said, "It's minus 20. And all he could ask me was, "Is that Celsius or Fahrenheit?" I'm like, "Seriously? Does it really matter?" Because it's cold like hell. It doesn't matter whether it's Celsius or Fahrenheit, right? So the point is, when it's so cold, what do? You know, I'm here nice with a t-shirt, but if you catch me at my home in the winter, I'm the guy who has 6 layers of clothing. I look about twice my size usually. And I'm like, "Oh, this is comfortable. Maybe I should find one more layer and put on." And you're like, "Really? Why do you wear 6 layers of clothing?" There's a very good reason for it. I've got adult children who are in college, and they come home, and the first thing they do when they come home is, "Gosh, it's cold here." I'm like, "Yeah, that's called winter." But things are nice in school. And I'm like, "Yeah, because we pay the bills, so it should be nice." And they live in a dorm, and it's pretty warm. And they come home, and I'm like, "Gosh, this is chilly." And then they ask my wife, "Mom, can we increase the heat, please?" And I often look at them and say, "No problem. Tell me where I can send you the bill. You can maybe pay some of the bill." And the conversation immediately is, "Mom, can you tell me where my old clothes are? I want to find them." And when you put responsibility into hands of people to say, "You need to share the bill if you're in my home," that changes the perspective, isn't it, immediately. So I can take the thermostat and make it all the way warm. And guess what? When it's really warm, it's very comfortable. But it's very hard on my wallet. And on the other hand, I put a few layers of clothes on. It does become a little bit more comfortable after that. Otherwise, it's very uncomfortable, but it's very comfortable to my wallet. So the question here is, I can make it really warm and pay a lot of price on the heating, or I can make it too cold and fall sick. But what is the middle ground I need to choose? That's a trade-off that I try to really choose. And so what I'm doing is not keeping the home cold or warm. I'm dealing with a trade-off. How can I spend enough but not more? But how can I keep it comfortable with maybe a few extra clothes that I can have on myself? This really takes me to something I think a lot when I write code. For example, I want to quickly go faster. I want to move faster. I want to get this coding done quickly. But I always think of this concept called local optimization versus global optimization. Local optimization, unfortunately, is what most of us think about. How can I do well in what I'm doing right now? I want to spend right now. I want to go out and do things right now. I want to spend my time on fixing this bug right now. So we often think about what is imminent. That's what we do. Global optimization. What impact does this have on my overall project? How does it help my company? How does it help my organization? How does it help my long-term savings in retirement? How does it make a difference to my health in the long run? When I'm 70 years old, how healthy or unhealthy am I going to be? Am I thinking of that when I am 20? So the local optimization, I'm thinking about my day when I'm 20 years old. Global optimization, what is that going to do to me when I'm 70 years old? And oftentimes we think about the local optimization and we tend to forget about global optimization. But a lesson we can learn from Toyota, for example, they say base your management decision on a long-term philosophy, even at the expense of short-term financial goal. And this is something I wish more of us can at least think about on a daily basis, because we are so eager to run our projects to ground because we are working towards this senseless artificial deadline we created and being hypocritical about it, rather than asking the question, what does it do to us in the long term? Why are we running towards this madness as if there's no end to this, instead of asking, how can we take a balanced approach? Is this going to really hurt us? Is it going to really kill us? But can we really think about maybe altering the scope so we can deliver better value than to push more with poor quality? So long-term versus short-term. So I often tell myself, survive in the short term, but succeed in the long term. You cannot ignore one versus the other. If you don't survive in the short term, there may not be tomorrow. But if you only focus on surviving in the short term, you may not really have that future in the long term. And we see this a lot in our own societies. We can focus on today forever, but then there is a day when there is no tomorrow because we've been focused way too much on today. So it's a balance we have to strike again. How can I survive in the short term without compromising my ability to succeed in the long term? This is true financially, this is true health-wise, this is true from a corporation point of view, this is true in almost every aspect of life, is something we have to think about. So my focus these days is the word sustainability. I don't care about speed, I care about sustainable speed. I don't want to compromise my ability to survive in the future at the expense of running fast today. And that is something I want to keep thinking about. How can I be sustainable in what I do? So living is an act of trade-off, but programming is how we make a living for a lot of us in this room. So I want to bring this back to programming and talk a little bit about what can we do to really benefit from these ideas when it comes to programming and how we can benefit from that. Well, let's think of the evolution of software from back in time. We did waterfall development. This is what I started my programming career about 35, 40 years ago. When I was a young programmer, waterfall was the way of doing it. There's a very clear difference between what we did then and what we do today. And that's what is amazing, I think. Back in time, we did waterfall, and we called it waterfall. Today, we do waterfall, but we call it agile. I just love it. It's amazing, right? So what do? We are agile. I'm so glad we got that out of the way. Now let's talk about what you actually do. And so we like to really say these things that make us feel better, right? So we did waterfall, and we said we did waterfall. We didn't have any shame of that. But you may ask the question, what's wrong with waterfall? Let's be honest about it. There's nothing wrong with waterfall, except one simple thing. And that is, in the waterfall, we kept doing things until one day we did things that you could actually notice. And that time came way late in the game for us to do anything about it than to panic. So almost no plan succeeds when the feedback comes really late in the game. That was the problem with waterfall. The whole idea of agile development, at least in concept, was to bring that feedback loop early in the game for those who want to use it. But of course, today, well, we used to do this big upfront design. That didn't work. But today, we do agile development. What does that mean? That's lovely, because what that means is no design. Let's code it. And you go to them and say, how does this work? Don't worry about it, we are agile. How does this work? Don't worry about it, we are agile. Have we thought about what this feature should be? Don't worry about it, we are agile. Because we are told that we shouldn't think, we shouldn't plan. Who would plan after all? As it turns out, planning is so important that in agile development, we do it constantly. That's what we call as adaptive planning. If we don't do adaptive planning, then there's no point in celebrating agility. So a planned design did not help us. We learned that lesson 40 years ago. But today we do this emergent design, which is a disaster we are living in. And that's not working either. So we need to really ask the question, is this working for us? Rather than saying, don't worry about it, we are agile. So maybe we need something in between to really rethink about it. An evolution design, but with enough upfront design. Not a lot of design, not no design, but what if we can do enough upfront design? And this is the part I feel is missing in a lot of teams, is that we are not doing these efforts that we need to do to get successful. I'm a huge fan of programming. But it turns out there are languages that provide what are called design by contract versus languages that provide what are called design by capability. And I used to program back in time with C++. Yes, I always say, if you program in C++ in your life at least once, you can do anything you want in life. Because I've taken the maximum pain in one shot. And I used to write code in C++ for commercial projects. That's where I spent most of my youth, programming in C++. And then, of course, I feared languages like JavaScript. I wouldn't touch them. I'm like, are you kidding me? Why would I want to program in a language like JavaScript? And as years went by, I had some really good friends whom I respected and I admire. And they were programming in dynamically typed languages. I was like, wow, these people are actually nice people. They are succeeding. And yet they are programming with something completely different from what I'm doing. And then, of course, that's also the time I started embracing this idea of test-driven development. And I remember that day when I realized that I need to really start doing more thorough test-driven development. And the time almost when I embraced test-driven development is also the time I started embracing dynamically typed languages as well. And today, if you ask me which one is better, I'm not going to give you a straight answer because I don't really know which one is better, honestly, because there are pros and cons for each one of them. Design by contract is great. We got fewer runtime failures. Compiler checks are awesome. I would rather have a compiler tell me how really bad my code is than my users tell me eventually. And of course, you can have conformance of your code as well. So there are benefits, certainly. But at the same time, design by capability, dynamic type languages, they offer me a greater amount of extensibility. I've written commercial projects where we exploited meta programming to the extent we cannot in a statically typed language that we have today. It's very evolvable, it's extremely flexible as well. So as it turns out that I've got two different capabilities on my hand, and if I tell myself one is right, the other is wrong, I completely ruled out the benefits of one way of doing things, and I'm settling only for half of what I'm available. So when it comes to dynamic type languages, there are certain things we can benefit from. For example, what if I tell you we need to have cars that are rugged, robust? Oh yes, of course, cars have to be really safe. What if we build a car with only steel and nothing else? That's it. Everything is steel blocks. That's not a car you would want to drive in. So you have cars with absolutely very, very solid parts in it, but you also have cars which have parts which are spring. I mean the metal spring, not your framework. So essentially, there's malleability we need in places to absorb the shock. That's what makes a pleasant driving experience. And that's exactly what programming is. For example, this notion of a language pyramid that Ola Binney talked about years ago. And he talks about what if your application is built with a stable layer, followed by a dynamic layer, and maybe a domain-specific layer on top of it. Well, this can give you the flexibility to build enterprise systems more effectively rather than just sticking to one way of doing things. And again, as an example, what if you have a Java or a Scala, as an example, could be Kotlin, or could be any other languages, Rust, for example, or maybe a layer of Ruby or Clojure or JavaScript or whatever language you can think of on the layer above it, and maybe a DSL layer you can create on top of it. Well, as we can see, we need different languages to give us these kinds of flexibilities in general than sitting to one thing. Same thing with design principles. I can't tell you how many times I'm doing code reviews for my client, and I look at a very complex code, and I ask them, my gosh, this code is a monster. Why did we do it? And their answer is because we wanted to use these design principles. If using principles make you write bad code, you got to rethink about the principles you are using or how you're using the principles. So principles are useful, but we got to really know what we are doing with them. For example, a quick show of hand, is reuse important? A few hands go up, a lot of hands go up, great. Sure, absolutely, right? We've been taught this lesson, reuse is important, absolutely. What do you think? Should we have more coupling or less coupling? How about less coupling? The hands go up, about the same as we saw earlier, right? How about more coupling? Only a few of us, right? And a few like, nah, maybe not. Okay. But then, should we increase or decrease duplication of code? Duplicate code more. Who says that? A few of us, right? No, not really. Yeah. So we don't wake up in the morning saying, I want to go to work and duplicate code today, right? Not a great strategy to go to work for. But as it turns out, a lot of these are in opposition to each other. I want to reuse code, nice idea. But I want to reduce coupling, bad idea. You can't have both. As it turns out, if you have low coupling, you also have low reuse, because reuse increases coupling. So when we look at these concepts in isolation, we can say yay or nay. But when we put them together, we realize, no, you can't have them all. So you have to compromise. So to ask the question, if I want high reuse, I may have to increase coupling. If I want to really decrease coupling, I may have to really duplicate a few things in a proper way. And this is hard for a lot of us, because if I tell you, don't reuse, increase duplication, you're like, get out of the building. But on the other hand, if we say, well, but given these two, what should we do? And now we are like, okay, let's talk about compromising. And this is where the trade-off really comes in. And I will share with you one story that really hurts my feeling. You know the name of this company, I'm not allowed to say it here. It's a very large insurance company, not far from here. And I was sitting there at their office working on a code, and I asked a question to this programmer. I really wish he had said no, but he didn't say no. And I looked at a class and I said, excuse me, can I see the database schema for this class? Can I see the table? And he said, sure. And he opens the schema and shows it to me. I'm looking at the schema. I'm in a state of shock. I looked at him and said, oh, excuse me. He's like, yeah. And he had no emotions. I said, yeah. He said, yeah. This table has thousands of columns in it. The schema has thousands of tables, and every table contains 800, 900 columns. He's like, And I said, why? He kind of shrugged and said, because they need it. I said, who is they? He said, you don't understand. We're an enterprise. And we have thousands of applications that use the data. And that was their universal data model. Think about this for a minute. You maybe go for an interview in this company. And as you're having a good time, they say, we got a great cafeteria. Let's go have lunch and then come back and talk more about your job. And you go to the cafeteria, you find people are just having a great time. And truly having a great time. On one end of the room, people are talking about the politics. On the other end, it's even worse. They're talking about the JavaScript frameworks. And as you're looking at these things, you look way back in the room, away from civilization. There is one person alone facing the wall and quietly eating. And you said, who's that dude over there? They say, we don't talk about that person. You said, no, what happened? Oh, he tried to change the schema 3 weeks ago, and he's on a timeout. Bad things happen if you try to change the schema, isn't it? So when you walk into the company, what do they tell you? They pause you at the door and say, welcome to work today, please don't screw up. Because their problem is not of agility, but it's of stability. They don't care about agility. That went through the door a long time ago. They care about stability. Don't mess up anything, because if you screw up today, 500 applications will quit working, and you will have the timeout for next week. So the point really is, when you have a shared database and a unified data model, what actually went wrong? Think about this for a minute. If I come to you and say, I've got a great idea for you. I want you to write a class with only public fields in it. You're like, run that baby again? I want you to write a class with only public fields in it. You'll probably take me to the highest floor in the building and toss me out of there, right? Because it's insane to tell you to make everything public. Why? You say, have you heard of encapsulation, Venkat? Now think about this for a minute. When you use a shared database across multiple applications, what did we lose? Complete lack of encapsulation. The minute you realize that a unified data model that's shared between applications is lack of encapsulation, you're like, I don't want to touch this anymore. Because we don't think about that in that frame of mind. But when you think of this as a compromise on encapsulation, we frown on ourselves. Gosh, why did we do that so far? That's a question we want to ask. So on one hand, we have encapsulation. On the other hand, we have reuse. As it turns out, it's up in the toss. It's a compromise as well. If I increase reuse versus if I lower reuse, what is the compromise on encapsulation? I am compromising encapsulation on one hand versus increasing on the other. We need to be careful about it as well. So we're not saying duplicate data with vengeance. That's not the goal. But reduce duplication, but prioritize on encapsulation. This is what we try to do more so in distributed systems, and especially in the world of modular monoliths and microservices, for example. But why is the question? Not because it's fanciable. It's because it makes the people in this room happy. It's because we want to really focus on bringing more business agility. So asking the question, why do we want to design? We want to design to meet our business needs, not because we want to design because we can be happy with the purity of the design we create. I don't want my design to be pure. I want my design to be functional, so it serves my business for their needs. That's the real goal we are trying to strive. So we need to really take the time to evaluate trade-offs. So we are not making these flip decisions, but instead constantly asking trade-offs. One of the worst things we can do as programmers is to have biases in our minds, whether it's one way or the other. For example, I'm a huge fan of functional programming. I love functional programming. You can go to YouTube and put my name and you can see all the things I talk about functional programming. I love it. But is functional programming the right thing to do all the time? I've got some friends who tell me it's functional or you can take the highway. Everything has to be functional in nature. We are good friends. We do meet for dinner. We just agree not to talk about this stuff anymore. Because I think that's a terrible idea. Yes, functional programming is great, but there are times when that's not the right choice. Imperative style is very familiar to us, but also imperative style is damn good in handling exceptions. It's a complex model that shines when you have to deal with the complexity of exception handling. And it really can give you some raw performance where it's needed. On the other hand, functional programming reduces accidental complexity. I love functional programming for that purpose, for that reason. However, it is also easy to maintain. It's also easy to parallelize. But the minute you bring exception handling into functional style code, it becomes dysfunctional. That's the problem with functional programming, is it is really, there's a scale to which it's great, beyond that it falls apart. And the more we try to put tapes on it to hold it together, it becomes horrible to maintain such code. And there's a time when we have to say, that's a great idea, but not for now. And that is, again, a trade-off we have to evaluate. And there are times I write code in functional style. There are times I would like to be happy to switch over to imperative style. But the beauty is, I have the power of these tools on my hand. I don't have to submit myself to one way of doing things when I can benefit from switching the ways I do things for a better improvement on the project I'm trying to deliver. Same thing with maintainability and performance. You can make the code easier to maintain. You can improve performance. But there's a compromise here between the two. Scalability and performance similarly. You can increase scalability, but consequently you may decrease performance a little bit. And you cannot really have superb of two at the same time. I was mentioning this in one of the talks, and one person raised their hand and said, but we do that. I said, and what do you spend on it? And he said, billions of dollars. I'm like, I rest my case. So not at a reasonable cost. And there's a compromise that comes out of it. I was working on a team when we had a young developer writing Python code while we were developing Java code. That's okay. And one day, this guy comes into the room, sits down with a thud, and visibly angry. I said, having a rough day at work, aren't we? And he's like, I just came from this other room. I'm really angry. The guy loves Python. And I said, what made you angry? I just saw them write horrible, horrible Python code. I'm like, I can see why you're angry now. And then he said, Venkat, let me ask you the question. I asked them why they write such a horrible code, and they say they need to do so for performance reasons. What do you think, Venkat? Do we have to write bad code for performance? And I told him, I won't answer the question for you, but does the code have good performance? He said, that's the problem. It doesn't. And that is one of the problems we have to deal with. So don't ask, is the code fast? I cannot tell you, this is the one I cringe. I show something to people, oh, how does it perform? As if performance is the only thing we want to know about. This is the worst question you can ask. You're cheating yourself asking this question. Don't ask, is the code fast? If I ask you, I've got 2 cars I can buy, one that can take me to 120 miles an hour, another that can drive 250 miles an hour, which one should I buy? You're going to ask me, excuse me, where are you going to drive this car? Oh, in the middle of Boston or Bangalore. Yeah, thank you. That sums it up, right? You're like, dude, get a bicycle. Because you're not going to get anywhere more than 70 miles an hour in either of those cities, right? So the question you want to ask is the speed adequate? This is the question we need to be asking continuously. Is the performance adequate? I don't care how fast it is. Is it adequate for what I want to do? As it turns out, the more we think about it, the end result of worrying about performance often is the worry, not the performance. And so somebody taught us the wrong lessons back in school maybe. And they told us, what about performance? And everybody's like, oh my gosh, I got to think about performance. So the question is the performance adequate? Not if it is super performance, because most of the time we don't care. But by caring about performance to that level, we compromised on maintainability of code oftentimes. And if I say I can improve the performance by parallelizing it, you're going to start laughing. I can't even touch this code. I can't parallelize it. So the question you want to really ask is this. Those who sacrifice quality to get performance may end up getting neither. And this is the lesson I've seen over and over and over, is that we are so hung up on one thing that we lose everything in that process. And so we have to really ask the question, how can we compromise between those to get the results? So whether performance is truly a concern, then write a test for it. I've seen so many examples in companies where they spend so much time optimizing performance, and 3 months to 6 months later, they're redoing the whole work. Why? Because they never had a feedback loop to tell when they are deviating from the performance they worked so hard for. So designing and architecting is evaluating trade-offs. That's what we do every single day. So identify the essential characteristics of what you're building. That's where we need to spend the time understanding why we are building things and what we are building. Prioritize on what is really important for you to build, and don't get infatuated on things that are just peripheral and can help us to focus instead on real problems. Evaluate the trade-off continuously. and be willing to put them on the table and discuss the compromises so we can arrive at a more sensible decisions as we do. Don't make binary decisions because very few things are such binary in life. Decision making is an optimization problem. That's what it is. There are many solutions to the problem. Don't get hung up on one answer because that's what you like hearing. And decision making is also an act of considering compromises and evaluating compromises. So the most important thing to document in what you do is the why. Why are you making these decisions? Not what you made, but why. And the most important sensible answer you can give is it depends. Because it depends on what we do. I hope that was useful. Thanks for your time.